Okay. Hi, Assalamualaikum. My name is Muhammad Ashmaan bin Muhammad Fazil. My matric number is 2025124123. Okay, my task is double integral, which is the first question. We have a dz dy. And then when we put the equation in the GeoGebra, we got this graph. And as we can see here, we also can see the intersection 1, 2, 3, and 4. So this is the equation that we got, but we assume z as a x because in GeoGebra for graphy 2 dimension, we don't have a z axis. So first we should integrate the dz first. And then when we did integrate it, we gonna got this. We absolutely done for integrate for dz. We got this equation. But for me, I choose to separate to part 1 and part 2 because I feel more comfortable to calculate it. So for part 1, we separate to this equation, which is this one for the right hand side. So at here, we should use the substitution. So when we use a substitution method, we should change the limit to. So this is the way how to change the limit. And then we go to calculation, and then we got this answer for this only answer for part 1. Next, we go to part 2. We do the same work at part 1, and we got this answer. As we all know, we was separate the equation to part 1 and part 2, then we just combine it, and then we got this answer. Okay, next is for question C, which is we use reverse order. For the reverse order, we should change the dy dz position. At the original equation, we can see the equation given is dz dy. So we just change the position. But based on the graph, we should separate the region because we got the intersection here. So we got the region 1 and then region 2. So we can got a different equation, which is this is the equation. So this is the region 1, this is the region 2. So the limit we should take it from the graph. So for the region 1, we just calculate it, we do the integration. For the first, we respect to dy, and then for the second time, we respect to z, and then this is the answer. When we got this answer, we cannot integrate it like usual, but we should use by part method. So this is the by part method, and then this is the formula. Then after we calculated, we got this answer for region 1 only. For region 2, we do the same thing. We do the same work like region 1. After that, we're gonna got this answer. As we know, we was separate the region, then we just combine it together back. Then we got this answer.
My name is Muhammad Irfan bin Junairi. I mean, my number matrix is 2025394707. For the task 2, this is a diagram for the task 2 where we apply the equation is x is equal to z squared, z is equal to 0, and x plus z is equal to 1. This is a projection of the x-axis, y-axis, and z-axis. For the equation is we make an assumption where y is equal to 0 and y is equal to 1. And for the z1 and z2, we use a quadratic formula of z squared plus z minus 1 is equal to 0. We place our limitation in our equation, which for dx is z squared and z minus 1 minus z. Dz is 0, negative 1 plus 5 per 2, and dy is 0 to 1. We make our integration, and the final answer we will get is negative 7 plus 5, so 5 per 12. If we make a correct equation for the x, y, we will get the same answer of from the x-axis, and for the z-axis we make a two area, which is R1 and R2. We place our limitation in the R1, which is for the dz is 0, set x, dx is 0, 3 minus set 5 per 2, and dy is 0, 0, 1. And our region 2 is dz is 0, 1 minus x, dx is 3 minus set 5 per 2, 1, and dy is 0 and 1. For the region 1, we make a simple make a calculation, and we will get is 2 2 per 3, 3 minus 5 per 2, power of 3 per 2. And our region 2 is we get 1 per 2 plus 1 minus 5 per 4, and we combine the region 1 equation region 1 and equation region 2, which is we get the same from the x-axis and y-axis, which is negative 7 plus 5, 5 per 12.
Yeah, Assalamualaikum. My name is Nur Firdaus bin Soeharto, and my ID is 2025130587. For task 3, we are using GeoGebra to find the shape of these two functions, and we got this picture, and this is our projection. For task 3, we evaluate the triple integral by converting it into cylindrical coordinate. The given solid is bounded by the cylinder and paraboloid. We first convert the Cartesian equation into the cylindrical coordinate using the substitution. X equal to r cos theta, y is equal to r sin theta, x squared plus y squared is equal to r squared, and dv is equal to r dz dr d theta. From the boundary equation, we determine the limits. Theta goes from 0 to 2 pi because the region is completely circle. R goes from 3 to 4 based on the inner and outer cylindrical surface. And Z goes from 0 to square root of 16 minus R squared according to the upper surface. Then we form the triple integral in cylindrical coordinate by substitute the variable, and then we integrate with respect z followed by r and finally theta. After the simplifying the result, we obtain the final answer shown in the solution. Therefore, this complete task 3, and the answer is 343 times 2 pi over 12. And for the task 4, this is a spherical coordinates. This is our diagram for question A. Next, I will explain task 4. For this equation, we solve the triple integral using spherical coordinates. The coordinate transformation are x equal to rho sine phi cos theta, y is equal to rho sine phi sine theta, and z is equal to rho cos phi. And the volume element is rho square sine phi d rho d phi and d theta. From the diagram, we determine the limits. Rho range from 0 to 1, theta from 0 to 2 pi, because the region lies in the region at the first quadrant. And phi we determine with trigonometric cos 2 times square root and 4. Next, we form the triple integral in spherical coordinates by substitute the variable including dv, and we integrate with respect to rho followed by theta and phi. After simplify the expression, we obtain the final answer, approximately 188.447. And therefore, this complete task 4. Thank you.